Alright, so up until now in your math careers, you've used degrees to measure angles, but that's not good enough anymore. We're going to start moving into more theoretical stuff. And in order to have theoretical stuff, we have to get our domains the same. So what I mean is when we use sine, cosine, or tangent so far, you're talking about angles that you're somehow changing into numbers. It's not a number that's getting put through to a number. So the domain is in degrees and the range is in numbers, and that's not going to be good enough. We need to have the domain and the range both be numbers. So what we have to do is introduce the radian. So here's a good video to show you how radians work. Take a generic circle with radius r. If you measure a distance along the circumference of that circle that's equal to the radius of the circle, r, then you can draw a line connecting the center of the circle and the end of that arc. Okay. The angle that you've created is now 1 radian. The reason you do this is because now instead of having some random number represent the angle, you are relating the angle to a distance. So both the input and the output of a trig function are going to be some sort of measurable real number and not a degree. So if you measure 1 radius length along, that gives you 1 radian. If you take and measure along the circumference of a circle twice that, or 2r, then that angle will give you a measure of 2 radians. And we can keep going. If you measure along the circumference of a circle 3 times the radius, okay, or 3r, then that angle is going to give you a measure of 3 radians. So what would happen if we took a measure of the entire circumference of a circle? We measured the arc all the way around the circle, which we know would be 360 degrees. Well, the circumference of a circle has a formula. That formula is 2 pi r. So just like in the previous ones, if 2r gave me 2 radians and 3r gave me radians, then 2 pi r will give me 2 pi radians. So what we find out here is that the circle, the entire circle, one rotation around the circle, which is 360 degrees, is now 2 pi radians. Now, just to simplify that equation, I can divide both sides by 2 and get the big money answer, which is that 180 degrees is equivalent to pi
so here we
radians.
I wrote 180 over pi because over here I'm going to show you how to go from degrees to radians, and over here I'm going to show you how to go from radians to degrees. And the way we do that is all with this formula. On this side, I divide both sides of the equation by 180. And that gives me 1 degree equals pi over 180. Okay, so if I had 2 degrees, it would be 2 pi over 180. If I had 3 degrees, it would be 3 pi over 180, and so forth and so on. So it just goes like that. You just multiply however many degrees you have times. So to go from degrees to radians, again, you take whatever you have times pi over 180. And I did that by getting 1 degree isolated by itself. So over here I'm going to get 1 radian isolated by itself. So I divide both sides by pi. Okay, so what that's going to give me is that 1 radian equals 180 degrees over pi. So, just like this one, that way 2 radians would be 2 times 180 over pi. 3 radians would be 3 times 180 over pi. So that means that to go from radians to degrees, it's going to be times 180 over pi. Okay, so the easiest way to remember it is to remember that radians usually have pi on the top. So if there's a pi in the numerator, right, you're going to get that if you multiply times pi over 180. And if there's a pi in the numerator and you multiply times 180 over pi, that's going to cancel out the pi's. So that's going to give you degrees. Okay, so you're either multiplying by pi over 180 or by 180 over pi. And I'm going to do a couple examples of converting degrees to radians and then converting radians to degrees. So we're going to convert 3 degrees into radians. And then the next slide we'll do 3 radians into degrees, and then we'll be done. So we got 45 degrees, we got negative 270 degrees, and we got 249.8 degrees. So we'll start with 45 degrees. And remember on the last page I told you you're always taking the degrees times pi over 180. Because I remember, oh yeah, radians usually have a pi on the top of the fraction, so I better have a pi on the top of the conversion factor. So I do 45 times pi over 180. Okay, and that's like 45 over 1. Remember, this is not cross multiplying, because cross multiplying means you have an equal sign in between the two. So what that gives me is 45 times pi gives me 45 pi over 180. Okay, and now I have to simplify that fraction because it's not simplified. 45 goes into 180. And I know 45 times 2 is 90, 45 times 2 is 90, and 2 times 90 is 180. So 45 actually goes into 180. Let's see how many times. That's a bad thing to do. It goes in 4 times. Okay? It's 4, 5 times 4, 0, 2, 16, 18, 180. Oh, look at that. Okay, so we know that 45 goes into 184 times. So that means we take this fraction, 1/4, and we don't have to write 1 times pi, because 1 times anything is itself, so we can just write that 45 degrees equals pi fourths radians. And you'll notice I didn't use 3.14, I left pi as it was. I want you to use pi fourths radians. Don't put it in the calculator and give me a decimal unless I ask you to do so. So moving on to negative 270. Again, we do times pi over 180. That's easy enough because we're going to have negative 270 over 1 times pi over 180. Okay? That's going to give me negative 270 pi over 180. 270 and 180 have a common factor. It's 90. So this is 3, this is 2. So my fraction becomes negative, because it's negative applies to the whole fraction, 3 pi over 2. That is my final answer. The third one is slightly different, because the third one gives a dead giveaway that I'm not leaving it in terms of pi. I am going to round to a decimal. And that's because the problem itself has a decimal in it. It's 249.8. So I'm going to get out a calculator to do that. So I'm going to do 249.8 times pi over 180. And I'm going to put that in the calculator and just see what I get. Remember, to put over in the calculator is divided by. My calculator there. Hold on a second. Okay. So here's how it's going to go. Right? I put it in just like this. 249.8 times. And put parentheses when you make a fraction. Don't forget. Pi over 180. Okay, before I put it in, it looks like that. Hit enter. The answer is 4. Well, they use 1 decimal, so it's going to be 4.4 radians. And remember, if I don't put a unit, that assumes that I mean radians. Okay, last thing. We're going to convert these radian measures into degrees. I know they're radian measures because they don't have a unit. So, 9 pi over 4. And remember that what we do to go from radians to degrees, we would like the pi to cancel out. So we know it's either 180 over pi or pi over 180. Well, it's only going to cancel out if the pi is at the bottom. So that's probably what we're going to use. And in fact, it is. So we multiply it times 180 over pi. And the first thing we want to do is see what cancels out. Well, I know that pi and pi cancel out. Okay, I have 4 and 180. I know 4 probably goes into 180. So let's see how many times. That's 4. That's 16. 45. Oh, we did that on the last page. You should have known. Okay, so this becomes a 1. This becomes a 45. Okay? So it's pretty easy to multiply across now because it's just 9 times 45. 9 times 45, because this is 9 times 45, this is 1 times 1. So 9, 45 times 9, that's going to be 5. Carry the 4, 4 times 9 is 36 plus 4. It's 405 degrees. All right, so 405 degrees. That's my answer. Okay, now we'll move to negative 5 pi over 6. Okay, again, times 180 over pi. Oh, good. The pi's cancel out. What else cancels out? Well, the 6 is 1, because this is 30, right? 180 divided by 6. That's a horrible, horrible thing. 3, 18, 30. Okay? So this is 1, this is 1, so it's 1 times 1 on the bottom yet again. We just have negative 5 times 30. And it's going to be negative, so that's going to be 150. Okay, so that means that this is 150 degrees. Final answer. Now another dead giveaway that I'm going to need to use a calculator, I have 0.25. Okay, so I'm going to do 4.25 times 180 over pi, just like all the other ones, only this time I'm going to use a calculator. Here you go. They had 2 decimal places, so I'll do 2 decimal places. That's 243.51 degrees. And that's it. We're just going to have lots of practice problems. Next class, just converting from degrees and radians to degrees.